Hey everybody, today I will do another video. It's going to be on the same topic, multivariable calculus. And I will review some formulas. I probably not going to do a lot of problems, maybe just two simple examples, because I think the most important out of the whole topic of vectors is to know how to calculate the vector components. So I will just do maybe two examples and then I will jump into unit vectors. Unit vectors is another important part of this vectors in the space section. So I will cover a formula. It's called a distance formula, which is equal to basically, so it's something like this. D is equal to square root of the square root of x2 minus x1 squared plus y2 minus y1 squared plus c2 plus c2 plus c2 minus c1 squared, right? That is the distance formula in a three-dimensional space. Now, let's say that we have an example, right? So we want to calculate the difference between 2 points. Notice that I have x1, I got x2 minus x1, y2 minus y1, c2 minus c1. Every single unit gets quantity squared. So if you remember from my last class, I said that final minus initial, right? So final x2 minus initial, y2 minus y1, which obviously is y initial, c2 minus c1, which is obviously, again, c initial, right? Initial point, in other words, final point minus initial point is squared. Final point minus initial point is squared, right? Now, let's do an example. Let's say that we want to calculate the distance between 2 points. 2 points, right? So, for example, we'll say find the distance between points, between 2 points, right? 2 points, between 2 points in a space. Okay, so and let's say that the example, let's say they give us a point and they give initial point, right? Usually initial points, right, is the first one that shows up, right? So let's say there's one that is 2 comma negative 1 comma 3. 2 comma negative 1 comma 3. That is initial point. And the final point is 1 comma 0 comma negative 2. Okay, so using this formula, calculate the distance between those 2 points, right? Okay, so I get this number, right? So this is x1, y1, c1, and this obviously x2, y2, c2, right? Okay, so let's do it. So d is equal to what? D equal to D equal to what? Equal to initial final point minus initial point, right? So I got 1 minus 2 quantity squared, and then I got plus 0 minus a minus 1. Here I gotta be careful because it's a negative. I have to put a negative inside parentheses and another parenthesis and then square it. Then I got 2 plus minus 2, right? That's minus 2, minus 2, and then I got minus 3, right? So minus 3 quantity squared, right? Okay. Okay, so we do parentheses first. Again, this is events, little events calculus, right? Obviously, it's considered calculus 3. We're still using the basic principles of mathematics, right? Parentheses first, right? So we do what? We do D is equal to my positive 1 minus 1 is a negative 1, right? That gets squared. Plus 0, 0, right? I got 0, but I got what? I got 0 and I got a minus 1, so it's a plus 1, right? Because this is a plus, this is still 1 to the square. Plus negative 2 minus a negative 3 is negative 5, 1 to the square. Now, let's do the math. Square every single piece and add them together. I get what? I get D is equal to what? 1 plus 25. Right? So, and that is equal to exactly what I was going to do is 27, right? Under the square root. So it's equal to D is equal to 27 on this on inside the square root. But look at this number right here. What could I do with this 27, right? So with the 27, I can factor out a 9, right? Factor out a 9 because what? Because guess what? 9 times 3 is equal to 27, and it's equal to D is equal to what? Is equal to 9 times 3. See that? This is what I did. All I did is factor out the 9, and I got 3. 9 times 3 is equal to 27, right? So I broke it into factors of whatever factors I get in 27, which is 9 times 3, right? So then I can take the square root to what? I can take the square root of 9, which is 3. The square root of 9 is 3. And the answer for that is 3 radical 3. Okay, so that is basically that example. Like I say, this is not really complicated, so I'm not going to go over a lot of this. Too many examples in this topic, in this little section of the distance formula. Okay, now let's do another formula. I might not calculate the, because this is this type of math is in different, it's in pre-calculus, I think. But I just will do, just because it's in the book, it is in the section. Okay, so the next one is the formula for an sphere, right? Formula for an sphere is, which is, this is a little bit different, but again, I'm not going to be drawing in a vertical shape in the board, three-dimensional. I'm not going to do that. I will just do the basic formula and show you guys how to use it. This is not really too bad either, right? So we have a point, right? So we have a point, initial point, at the center of an sphere. It has an S. I don't think it has an N and an AN, but this is not an English class anyway, so this is math class. So, okay, so at the center, right, of a sphere, at the center, right? So we have an initial point, and that point is what? That point is, it's like this. x0, comma, y0, comma, z0, right? Now we have another point which is located somewhere, right, on this sphere, and it is located at the H, or at the, I will say at the somewhere in the tangent line, right? Right. So we have this point at the center. Then we have another point at the edge, right? Which basically is the radius, right? That was we're looking for the distance from the center to the edge of the sphere, and that is the distance. That's the radius, right? So now, in that point, we call it what? We call it that point, we call it simply x comma y comma z. Okay. Now, then how do we calculate the distance, right? R, right? So let's do something like this, okay? Let's say, for example, I want to calculate that, right? So remember last time I did final minus initial, right? The same thing. X minus x0, y minus y0, z minus z naught. Some people say z naught, right? X minus x naught, y minus y naught c minus c naught, right? Okay, so in that formula for that is simply what? It's simply x minus x naught. This is squared. Everything is squared. Plus y minus y naught minus this square plus c minus z naught y naught squared is equal to r squared, right? And that is the distance. That is actually the equation for a sphere, right? Now, what if I want to find the midpoint segment of that, right? The midpoint segment. The midpoint segment is simply combine x2 plus x1 plus x2, y2 plus y1 plus y2, and so forth and so forth. Divide each segment, each of those pieces divided by the half. Right? So this is the formula for calculating the radius of the distance from the center of an sphere to the, I will say, that tangential surface, the surface of the sphere, right? And then, so the midpoint is simply the joint segment of S1 and S1, Y2, S1, X2, Y1, Y2, C1, C2, right? So here is the following. So, okay, so X1 plus this is, let me just write it down. Like I say, I'm not gonna be using it. If you need to use it, then you can use it, but I'm not gonna be solving a lot of problems with this. So this is a segment. This is midpoint segment. Midpoint segment formula. Okay. So in this case, we got x1 plus x2 over 2 plus y1 plus y2 over 2 plus c1 plus c2 over 2, right? And that is the midpoint segment formula, right? Okay, so let's do one problem just to see it, just basic example. Okay, so let's do it. Okay, so calculate calculate the midpoint, right? Okay, calculate the midpoint at the following. Okay, let's use this formula back here. So the midpoints, the point that they give us 5, comma, -2, comma, comma 3. Right? And then there's one point, and the other point is what? N 0, comma 4, 0, comma 4, comma minus 3. Right. Okay. So I'm going to calculate the midpoint on this, right? That's what they want me to do. Okay. So notice that I already have the values, right? This point go with this point. This point go with this point, and this point go with that point, right? Let's do it. So midpoint is equal to what? Equal to the following, equal to 5 plus 0, 5 plus 0 over 2 plus, I can put parentheses around, right? Then minus 2, minus 2 plus 4 over 2 plus 3 minus 3 over 2. Okay? So, midpoint, usually put MP for short, is equal to 5 halves, right? 5 halves, right? Put a comma there. I think this is divided by commas. Yep, divided by commas, right? So here I get 1 half. When I do this, I get what? I get 0. 0 over 2 is simply 0, right? And of course, that is actually right here. I made a mistake. It's right here in this point, because see, right here, you gotta be careful with this. You're going too fast. So it's 2, right? So obviously when I add those 2, it's 2, and then that becomes 1. That 2 right there, right? Right here, let me just do it. Becomes half, comma 1, comma 0. So yeah, so 2 divided by 2 is 1. So therefore, that is the answer. Okay, so that is the using the midpoint formula, right? So now using the spherical type Okay, so they have a little example right here. Okay, so let's do an example real quick about, so we got the formula, we got x1 minus 0 minus x0 square, the square plus y1 minus y0 the square plus c1 minus z0 square, that is equal to r, right? And of course that is a square. Right? Okay, so Let's use the same. Now let's use the values that we found on this, right? And let's say that the midpoint is equal to, let's see. Actually, let's use the same values. The same. That's what they did, right? So here I got, for the points I got 5, 5, comma, negative 2, negative 3, right? 5, comma, negative 2, comma, 3. That is initial point. Final point is equal to what? Is equal to 0, 4, negative 3. 0, comma, 4, negative 3. Okay, so now I am using this formula, right? I want to calculate the distance of r, right? Okay, so let's do it. So in this case, I am doing 0, right? This is final. This is my final point. And this is initial point. Okay, so 0. Then what? 5 minus 5, 180 squared, plus. Let me just write it to the left here so I can have more room, because it's going to take a little bit of space. So it's going to be 0, comma, 5, 180 squared, plus negative 2 minus 4, 180 squared, plus. Actually, no, this is the reverse. This is actually 4 minus 4 and then 2. Right? And then, because it's final minus initial, right? Final minus initial, final minus initial. Then I get what? 3, and this is also a positive. Yep, positive, right? And the 2 over here, remember, the 2 is negative, so I gotta be careful. Here I gotta put a minus here, and I put another parenthesis and a minus inside the 2, right? In the last point, which is the z, right? So I got a negative 3, and I got 3, 1 squared, right? It's equal to r squared. Okay, let's do the math. So this is going to be what? It's going to be 5, negative 5 squared is, negative 5 squared is 25, plus 4, right? 4, but that becomes a plus. It's going to be 6, right? So 6 squared is equal to 36, plus negative 3, and a negative 3 is negative 6, right? So negative 6, 1 squared is another 36. Then that is equal to r squared. All right. So here, basically, In this case, it's going to be 36, 72, 72, 7 is equal to 97, right? So the square root of 97, right? The square root of 97 is going to be the distance square root of 97, right? Right? As you take the square root of both sides, it's going to be actually, because this is a square, so I don't have to do that yet. So after I add those 97, right, and it's equal to square root of, it's equal to r squared. When I take the square root on both sides, r is equal to the square root of 97. That's it. That's it for these two examples, right? Using this type of formulas. Like I said, I'm not gonna go into too much details because it's now another topic that I'm going to cover real quick, and I'm going to do more examples in this. It's basically called the vector, the unit vector, right? So it also is called the length. Well, the length is technically it's a magnitude, right? But the unit vector is described as 1 over the magnitude of v, vector v, which is technically written like this. So technically written like this. So the unit vector v, right? So it's in the direction was v, right? And in the direction of v, vector v, is equal to, which is equal to something like this. V over the magnitude is described by this, and this is very important to understand, which is equal to 1 over that. It's equal to 1 over that magnitude, like that, right? And that is the unit vector, right? So this is equivalent to that, okay? And that's how we will actually, I need to put a little more stuff here. So let me just do this and then continue here. And then let me put 1 over the magnitude of v. And then that's going to be multiplied by v1, comma, v2, comma, v3. Just like that. Now this vector is the unit vector, right? This is unit vector. So this is important, right? This is a very important concept. Right. So now the vector, the first step in this is to find the components, right? That's the first step. The second step is obviously calculate the magnitude. And the magnitude is similar to find the distance. It's similar. So, I will do an example real quick. So, let's say that the points are, let's write it down here. The point of this vector that we're trying to find are the following. So let's say that the points are negative 3, comma, no, negative 2, negative 2, comma, 3, comma 1. That's point 1, right? That's the initial point. And then the terminal point is the following. The terminal point is 0, comma, negative 4, comma 4. All right? So that's what I got. Okay, now, remember last time we had to find the distance, right? Last time we had to find the distance, Q1, Q2, and Q3, and so forth, right? So how do we do it in this case? Well, it's going to be the same thing. In this case, it's going to be final minus initial, and so forth. So here, right? So let's calculate this, right? So let's say that B1, right? So B1 in this case is equal to this 0, right? So B1 is equal to what? Is equal to what? B1 is equal to final minus initial, final 0 minus 2, right? And then here, and then V2, I want to be doing them separate, then put them together because they need to be in this form, right? So, and then 2 is going to be this 4 here, negative 4 minus and plus, and then a minus 3, right? Then B3 is equal to this 4 minus 1, right? So this right here is 2, this right here is minus 7, and this right here is it's just 3, right? So now what do I have to do? Now I got this, right? I got the points, right? Those are the difference. Those are the numbers that we were looking for as far as components, right? Components. Now, what do I have to do? Well, the magnitude, I need to find the magnitude of V. The magnitude of V is going to be it's called the resultant, right? Well, magnitude actually. Magnitude and resultants pretty much. So this one is going to be the following. It's going to be the square root of this 3 values. It's going to be 3 squared plus negative 7 squared plus 3, actually it's 2 squared. 2 and 3 squared. Okay. So, doing the magnitude of this is going to be equal to what? It's going to be equal to vector V. The magnitude of that is going to be equal to what? It's going to be equal to 4, right? This is going to be 4 plus 49 plus 9. Okay, so in those, this is equal to, right here, 49 is equal to 48 plus 4 is equal to 62, right? 62, right? 62, right? So the square root of 62, right? It doesn't have any number that can actually go And that doesn't help too much to have a, to kind of break it down and reduce it down. But all I can do right now is the following, right? So all I can do is put that over 1, right? Because that's what it's telling me. Over 1, there's the magnitude. That's what I found, right? Over 1 and 62, right? Here, put a parenthesis, right? And I will put the values that I found. I will put 2, comma, -7, comma, 3. Right? So, that's what the answer for that is. Okay, so, and remember that this can be written when you distribute this across, right? Because this 2 is multiplied. You can leave it like this, right? This get distributed like that, right? So this one get distributed across, right? So I get distributed like that, like that, like that, right? So this can be reading as the following. It can be reading as the following. It can be reading as 2 over the square root of 62, comma, -7 over the square root of 62, comma, 3 over the square root of 62. That is also valid. This is also a valid answer, right? So that's how you do that. So that is the basically the point. You know that the book did not use these terms, right? I use it because they have it right here. The book has the formula. The book used Q, which is Q1 is equal to that, Q2 is equal to that, and Q3 is equal to that. Okay, so the same thing. I mean, again, all you gotta do is say that Q1 is equivalent to V1, Q2 is equivalent to V2, Q3 is equivalent to V3, and that's it. So, okay. So that's it for today. I hope you like this video. If you do, please give me a like and subscribe to the channel and share this knowledge with other people that they do understand this concept. And that's it. Hopefully you learned something. And remember, we over here at the Conservative Engineering Academy, we learn something every day because Jesus is good with us. That's it. Without him, we cannot do anything. Thank you for watching. God bless.